my name is Nurul Rafika binti Muhammad Hazal and my number matric is A23A1895. For this study, we analyze a life insurance data set consisting of 1,338 observations and 7 variables, namely age, gender, BMI, number of children, smoking status, region and insurance charge. So, the main purpose of statistical analysis is to collect, organize, summarize, and interpret data so that better decision can be made. In the insurance industry, statistical analysis is useful for identifying factors that influence insurance premiums and assessing customer risk profiles. The variable in this dataset can be divided in two categories. First, the numerical variable are age, BMI, number of children, and insurance charge, while the categorical variable and gender, smoking status, and region. So, to meet the assignment requirements, a simple random sampling method was applied using SPSS. We then conduct both descriptive and inferential statistical analysis. The independent sample test was used to compare insurance charge between smokers and non-smokers, while one-way ANOVA was used to determine whether insurance charge differs across regions. Through this analysis, we aim to identify the key factors that influence insurance charge and demonstrate the application of statistical methods and business decision making.
My name is Ainul Afika binti Ahmad and number matric is A23A2237. Today I will present sampling and data selection. The sample size was determined using the last two digits of our group members' matric numbers, which are 59, 37, 95, 03 and 93. The smallest number is 03 and the largest is 95. Using the formula given, the sample size is 500 minus 3, which equals 497 cases. The sampling frame is 500 plus 95, which equals 595 cases. Therefore, 497 cases were randomly selected from the first 595 observations. Next, the dataset was opened in SPSS. We went to data and clicked select cases. This function is used to choose which data will be included in the analysis. Then, we select the random sample of cases and click sample. This option allows SPSS to randomly select data. It was used because we need simple random sampling where every observation has an equal chance of being selected. We selected exactly and enter 497 cases. We also set the sampling frame to the first 595 observations. Then we click OK to run the sampling process. After that, unselected cases were deleted. The final dataset was saved separately and contains 497 cases. The sampling method used is simple random sampling. This method reduces bias and gives equal chance to all observations. Finally, the sampling process was successfully done using SPSS, resulting in 497 randomly selected cases from 595 observations.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anita Laini binti Abdul Rashid. My matric number is 823A2503. I will presenting a descriptive statistic. First, central tendency. We'll now go through the numerical descriptive measures computed from our sample of 412 respondents. We'll start with measures of central tendency. The age variable has a mean of 39.04 years, indicating that the average respondent in our sample is around 39 years old. BMI has a mean of 30.52, which actually falls within the obese category, since a BMI of 30 and above is classified as obese. This tells us that on average, individuals in this dataset carry excess body weight. For charge, the mean is 13,017 ringgit and 4 cents. However, as we'll see shortly, this mean is likely pulled upward by a small number of very high cost cases. Number of children children has a mean of 1.06, meaning the average individual has just slightly more than 1 degree. Moving on to measures of position, we look at the minimum, maximum, and range for each variable. Each range from 18 to 64, giving a range of 46 years, showing our sample covers a wide span from young adults to those nearing retirement. BMI ranges from 15.69 to 49.06, a range of 33.10. The most striking figures here is charges, which are a range of 62,633.42 ringgit. This range is almost 5 times larger than the mean itself, which is our first strong signal that the charge data is heavily skewed, likely due to a small group of individuals with exceptionally high medical costs. Number of children ranges from 0 to 5. Next, measure of variation. Using standard deviation to show how spread out the data is. Age has a standard deviation of 14 to 0.619, indicating age are fairly evenly spread across the 18 to 64 range without clustering around any particular group. BMI has a much smaller standard deviation of 6.072, meaning most individuals' BMI values are close to the mean of 30.52. The key figure here is charged with a standard deviation of 11,679.61, almost as larger as its mean of 13,070.04. When the standard deviation is this close to the mean, it's a strong indicator of high variability and right skewness, meaning while most people pay modest charges, a minority pay disproportionately large amounts. Children has a standard deviation of 1.165, reflecting that most individuals have between 0 and 2 children. Let's move to section 3.2, the graphical representation, starting with our pie charts. The gender pie chart shows an almost even split, 49.3% male and 50.7% female. This tells us gender is unlikely to be a confounding factor in our analysis. The smoker pie chart, on the other hand, shows a clear imbalance, 80.6% non-smokers and only 19.4% smokers. Although smokers are the minority, this group is expected to play a major role in explaining the high charge outliers. Here, we have 3 histograms. The age histogram shows a roughly uniform distribution across the 18 to 64 range, with one notable spike at the 18 to 20 age group, suggesting an unusually large number of young adults in the sample. The BMI histogram is approximately bell-shaped, peaking around BMI values of 27 to 30, which aligns with the small standard deviation we saw earlier. The charges histogram is the most important one. It clearly shows a right skewed distribution. Most individuals fall in 10 ringgit to 10,000 ringgit range, but there's a long tail extending out to over 60,000 ringgit. This pattern is consistent with the smoker subgroup we identified in the pie chart.
Next, hypothesis testing. Hypothesis testing is a statistical method used to evaluate assumption about a population based on sample data and support decision making using statistical evidence. It helps research test the validity of claims such as whether difference or relationship is between variables. A significance level 0.05 is used to reduce the risk of making incorrect conclusion in statistical analysis. An independent sample test was conducted to determine whether there is a significant difference in mean insurance charge between smoker and non-smoker. Hypothesis no significant difference is between the two groups. Hypothesis alternative, a significant difference is between the two groups. Okay, next, based on Fiogera group statistics, the data consists of 332 non-smoker and 80 smoker. The descriptive statistics show a clear difference in insurance charge between the two groups. The mean insurance charge for non-smoker is approximately 8,740 ringgit, with a standard DPR of about 6,441 ringgit. In contrast, smoker have a much higher mean insurance charge of approximately 3,875 ringgit, with standard DPR of about 11,630 ringgit. This This indicates that smoker generally pay suitably higher insurance premium compared to non-smoker. The less standard DPR among smoker also suggests greater variety in insurance change within the smoker group. However, descriptive statistics alone cannot determine whether the absolute difference is statistically significant. Therefore, an independent sample test was conducted to examine whether the difference in mean insurance change between smoker and non-smoker is statistically significant or simply due to random subjective variance. Next, I will explain the result of the independent sample test based on SPSS output. The independent test for equality of variance is significant with a p-value less than 0.001. This indicates that the assumption of equal variance is violated. Therefore, the result for the equal variance not established when used for interpretation. The independent sample test produced a t-value negative 60.455 and a p-value less than 0.001. Since the p-value is much smaller than the significance level of 0.05, the null hypothesis is rejected. This result shows that there is a statistically significant difference in insurance change between smoker and the smoker. The very small p-value suggests that the overall difference is unlikely to have encouraged by change. Therefore, smoking tests as a significant influence on insurance change individuals who smoker tend to pay substantially higher insurance premium compared to non-smoker. In conclusion, the finding confirms that smoking is an important factor affecting insurance and costs shall be considered when evaluating insurance risk and pricing strategy.
Analysis of variance ANOVA is a statistical technique used to compare the mean values of more than two groups in order to determine whether there are many significant differences between them. In this study, ANOVA was conducted to examine whether healthcare insurance charges differ significantly across the Northeast, Southeast, and Southwest regions. So analysis was based on two hypotheses: the null hypothesis HO, which states that there is no significant difference in the mean healthcare charges among the four regions, and the alternative hypothesis H1, which stated that at least one region has a significantly different mean healthcare charge compared to the others. Based on this descriptive statistic, the Southwest region recorded the highest average insurance charge, while the Northwest region had the lowest. However, the differences between the four regions were relatively small. Before conducting ANOVA, Levin's test was performed and produced a p-value of 0.552, which is greater than 0.05, indicating that the assumption of equal variances was met. The ANOVA result showed a p-value of 0.988, which is also greater than 0.05. Therefore, the null hypothesis cannot be rejected, indicating that there is no significant difference in healthcare insurance charges among the four regions. To further verify the ANOVA results, a Turkey HSD multiple comparison test was conducted. The results showed that all p-values were greater than 0.05, indicating that there were no significant differences between any pair of regions. This finding is consistent with the ANOVA results, which also showed no significant difference in the mean healthcare insurance charges among the four regions. Therefore, the null hypothesis cannot be rejected. Based on findings, region location does not appear to the major factor influencing insurance charge. That the difference in insurance costs are likely driven by other factors rather than rational differences.
To conclude, this study successfully applied both descriptive and inferential statistical analysis to examine the insurance dataset. The descriptive analysis showed that insurance charge vary considerable among individuals, indicating that certain factors may influence the amount charged. From the inferential analysis, the independent sample t-test revealed that smoking status has a significant effect on insurance charge. Smokers were found to have substantially higher insurance costs compared to non-smokers. On the other hand, the one-way ANOVA results show that there is no significant difference in insurance charge across the 4 regions. This suggests the regional location is not a major determinant of insurance costs in this dataset. Overall, the findings indicate that lifestyle factors, particularly smoking habits, have a greater influence on insurance premiums than geographical location. This result can help insurance companies improve risk assessment and develop more effective pricing strategies. That's all from me. Thank you.